This video is brought to you by PPLIR Europe, a not-for-profit community of European general aviation pilots dedicated to helping ourselves and others to use our licenses to the full. We share our passion for flying through mutual exchange of expertise, experience, information, inspiration, and education. We also assist regulators in framing legislation that affects all GA pilots. We're almost all volunteers and do it because we love it, though we do also need to raise a little money, mainly to fund our representation and lobby activities. Please join us, improve and broaden your own flying, enjoy belonging to a community of like-minded pilots, and help us represent you. Hi, this is a video about flying overlay approaches on the GNSS Navigator. Some time ago now, and I apologize for the long gap, I made a video about PBN, including RMP approaches. A link is in the comments. And many of the same considerations apply, but there are some significant differences. Most experienced instrument pilots have been using GNSS navigation to complement ground aids when flying instrument approaches for many, many years. But until recently, IR students have been taught that they must use the underlying aids. The result is that there has been little formal training, and many pilots are either self-taught or unfamiliar with using overlays. That is now changing at different rates across different countries in Europe. In 2022, regulations in both the UK and EASA introduced GNSS substitution in place of ground aids, effectively encouraging the adoption of overlays. As a result, national authorities are mostly allowing the substitution of overlays for legacy radio aids in both training and testing. Instrument rating pilots, whether students or long-time rating holders, should find it worthwhile to understand these changes and consider adopting them into their standard operating procedures. EASA plans to phase out NDBs by 2030, and these 2022 regulatory changes remove the need for them to fly any type of approach procedure except for NDB approaches, even where they are used for outbound or missed approach segments. So, what is an overlay approach? It can apply to ILS, NDB, or VOR instrument approaches, whether procedural or vectored. It allows the initial, intermediate, and missed approach segments to be flown in a very similar method to an RMP approach, following a coded GNSS database 3D path instead of using ground aids such as NDB, DME, VOR, or even occasionally just dead reckoning. Most existing legacy approach procedures have been coded by Jeppesen and appear in GA navigators as a magenta overlay. These complement approved RMP approaches, which are covered in the PBN video I mentioned before. So, what do we need to fly an overlay approach? A GNS navigator with a current database, CDI, HSI, or EHSI. The ground aid receivers required for the final approach segment must still be carried and technically used. This is most typically ILS DME, in which case DME is required unless there's an alternative on the plate, usually a radar range call-out, and in EASA countries, your DME failed in flight. If it is a VOR or NDB approach, then a VOR receiver or ADF must be carried and technically used. I use the word technically because most experienced GA pilots will fly a VOR and particularly NDB approach using the magenta line on final approach because it's more reliable and accurate, but that is not approved. If the guidance from the GNS navigator differs from the ADF, many pilots will follow the magenta line rather than the ADF, but this is not approved. An autopilot is also helpful, as it is with RMP approaches. So, what makes the overlay approach better than using the legacy aids? Firstly, it allows you to develop standard operating procedures consistent across all types of approach. The differences between each other and from RMP approaches become rather few and small. It's much easier to interpret an HSI CDI deflection than NDB single needle tracking, making the tracking much easier and more accurate. It eliminates the multitude of errors inherent in the NDB-ADF combination. It reduces the risk of some common pilot errors, such as misinterpreting plates and entering incorrect frequencies. If it has GNS or roll steering, autopilot can be used to track the whole procedure. Indeed, this is probably the main argument for having an autopilot with GNSS steering. It automatically provides clear guidance for the standard missed approach. The vertical profile of many overlay procedures is encoded in the Jefferson database. Some navigators show the required levels at each waypoint. Some navigators, such as GTN and G1000, support VNAV and can provide vertical navigation throughout the procedure, so compatible navigators and autopilots can fly the entire procedure using vertical guidance. However, there are also some negatives. The most common error I see in my students, and even with experienced instrument pilots, is to overlook switching from GPS to VLOC prior to the final approach fix. This results in having believable azimuth guidance, because the final approach is coded in the database with an LNAV enunciation, but no vertical guidance. Thus, it's only when the pilot spots that there's no glide path indicator, which could be past the final approach fix, that there's a problem. Some approach overlays or initial approach fixes are not in the database. This may be because it's impossible to code them using the tools at the designer's disposal. For example, offset DMEs appear to be difficult or impossible to code, so DME arcs based on offset DMEs do not appear. Because they're not considered important enough to fill the database capacity, or because of oversight. Many approaches have multiple versions, either different for different speed categories or alternative procedures. These are not, and probably cannot be, totally consistently coded, as overlay designers have a limited range of leg types to work with. As I'll be discussing in a minute, the way different versions of the approach are coded is usually confusing and unhelpful. In some older non-SBAS navigators, such as the GNS 430 without the W at the end, the track to the first fix on the missed approach is not reliable unless the sequencing is unsuspended only once you are above the first track to altitude leg. This means checking on the plate for the initial climb restriction and making that climb before unsuspending. If you do not, there's a real risk that you'll be turned early. Also, in some older navigators, the direction of turn back to the NDB is not reliable. If you are a little to the side of the climb out, they can take the shortest way back, which could be the opposite to the specified direction of turn. Both these issues are fixed in SBAS navigators, but you need to be very aware of them in pre-SBAS navigators, such as the GNS 430. Many navigators do not show the vertical profile. If they don't, or if your panel doesn't support VNAV, then you're entirely responsible for vertical navigation. So, let's now talk about regulatory approval, which came into force for non-commercial, non-complex operations in EASA from the end of October 2022. Pilots have long used these overlays instead of the underlying aid. However, before the regulations changed, the underlying aid had to be carried and turned on, and, at least technically, if the two differed, it was the legacy aid that had to be followed. Therefore, if an aid, notably ADF but also DME, was not carried, it was technically not approved to fly the approach. Now it has been approved to use the overlay approaches in all phases of the approach except the final approach segment. This includes the missed approach. So it's now permitted to fly a procedure where the underlying ground aid, e.g. NDB, is out of service, including for maintenance, and if the equipment is not carried in the aircraft. Let's talk about how to fly an overlay approach. Loading an overlay approach is very similar to RMP, with a choice of initial approach fixes referred to as transitions or trans in navigators. Ensure that your destination is the last waypoint in your navigator flight plan. This is not strictly required, as you can nominate the airfield when selecting the approach, but it does make life easier. If there are different tracks and distances based on aircraft speed category, typically the outbound leg on a teardrop procedure, they will probably all have the same initial approach fix. That initial approach fix is very often, but not always, an NDB of the airfield. Because it's the same initial approach fix, it will have the same designator in the database. This can be confusing. If there are different tracks and distances named for the same beacon, the same IAF is duplicated multiple times, such that normally the procedure for the fastest category appears at the top and the slowest at the bottom. You may have to scroll down to see that. This is best remembered as lowest is slowest. I know of only one exception to this rule, ILS 09 at London City, but this is extremely unlikely ever to affect anyone watching this video. Indeed, I would guess it's never been flown operationally. Nonetheless, it's an exception which proves the rule. Often, there are alternative procedures based on where you are and the direction you're flying. Such alternatives include extending the holding racetrack, reversal turns, DME arcs, and joins direct to the intermediate fix. Be sure to check what procedure applies to your aircraft. It could be A and B and C and D, or A, B and C and D, or some other combination. Make sure you check the outbound track and distance against the plate. Distances will be based on GNSS rather than DME, and sometimes are slightly greater because the DME has been artificially reduced to display 0 at the runway threshold. Even if you are flying a slower category, it's safe and generally acceptable to fly the track for a faster category, and may be wise if there's a strong wind blowing across the procedure towards the inbound track. In this case, ATC should be advised. It's important to check before you fly any procedure that the tracks and distances match those on the chart, as well as looking at the general shape. For example, here's the plate for runway 23 at Southend. Note an outbound track for Cat A and B of 043 and 9 DME, then inbound 233, 3 nautical miles to the final approach fix, 6 nautical miles to the missed approach point, a minimum time of 1 minute climb to altitude leg. Just as on RMP approaches, you have the choice of activating the approach or activating vectors to final. Activating approach means fly to the initial approach fix, then follow the procedure. This is also what's expected when ATC says cleared for the approach. The approach can be activated when it's loaded or later. Pressing direct to the initial approach fix has the same effect. If you're offered radar vectoring, you can hit activate vectors to final. This gives you a 30 nautical mile long extended centerline. For an ILS approach, you should change to VLOC just before you intercept or shortly after to enable the glide slope. It's wise to load the procedural approach in case radar is not available, and then press activate vectors to final when the controller announces that it will be a vectored approach. There are still plenty of non-RMP approaches in Europe which are not radar vectored, even at main international airports, such as Ljubljana, so it's always better to brief and set up the procedure. The missed approach is also in the database with vertical profile. At the missed approach point, sequencing is suspended, and it must be unsuspended to activate the missed approach. The missed approach point is generally at the threshold. There are exceptions for offset approaches and where terrain dictates an early turn, but that's the general rule. That means that there can be a long distance and time between you going missed at the decision altitude and the missed approach point. For example, with a 500-foot decision height in an arrow, it will be over a minute before the suspension caption comes up. In that period, you must continue to fly towards the missed approach point using horizontal guidance, but manually stop descending and start the climb. Wait for SUS to be displayed and then unsuspend to continue. Ensure you have switched from VLOC back to GPS mode. This happens automatically on newer equipment, but not on a 430. I repeat, it's vitally important on a pre-ESBAS unit to climb to the first altitude on the missed approach before unsuspending. If you don't, it can turn you early or the wrong way. Holds are at the end of missed approaches. If you need to fly the hold before the procedure, you must select the hold on the flight plan, i.e. as a part of the overlay approach procedure, and navigate direct to it. Overlay procedures on ESBAS receivers can be safely flown using GNSS roll steering. This is much less reliable on pre-ESBAS receivers because it can and will turn the wrong way in some situations. This is because the arcs between the legs are not calculated and the behavior of the autopilot is not predictable. So, let's do a summary and recap of the benefits. There are many similarities between overlay and RMP procedures. Selection of the approach procedure and loading into the navigator, activating the approach with autopilot, distances shown to the next waypoint rather than to the threshold, missed approach segment and hold embedded in the navigation sequence. GNSS scaling will switch to 0.3 of a nautical mile full-scale deflection when the approach is active. However, there are also a few significant differences. Procedures for different aircraft categories are shown with duplicate initial approach fixes. Select the appropriate category, lowest is slowest. You must ensure that navigation mode switches from GPS to VLOC prior to the final approach fix. You must ensure that navigation mode switches from VLOC to GPS on the missed approach. Some of the older non-ESPAS navigators may give erroneous guidance at certain points. I do hope that quick run-through of flying an approach procedure using an overlay has been useful. See you in the next video.